So welcome to this session. This session, you are going to introduce chain rules for function of several variables and see how we can apply the rule to carry out some differentiation. So chain rules. So rule or theorem number one. So I'll give the statement and then do an example to illustrate how that rule works. So this rule one is for the case whereby we have a rule for functions of one independent variable and two intermediate variables. So rule for functions of one independent variable and two intermediate variables. So let's take the rule. We say that if W is a function of X, Y, and Z, X and Y, and if we have X is a function of time and Y is also a function of time, are differentiable functions. Of T, then the composite function given by W equals to function of X of T, Y of T is a differentiable function of T and the W dt is given by partial W partial X times dx dt plus partial W partial Y times dy dt. So this is the rule number one. But dw dt is, this is a partial W partial X dx dt partial plus partial W partial Y dy dt. So let's label this one as 1. To clearly see how this formula is obtained, you can draw what we call the branch diagram. So the branch diagram we'll have we have the function w, which is a function of two variables, x and y. And so the functions, this is x, and then this is y. And then there's independent variable here, t. So you can join this, and then join this, and join this. So this one is what we call the dependent variable. So w is the dependent variable, and then x and y are called the intermediate variables. And then this t is called the independent variable. So you see now, in this arm, because now x depends on t. So here, on this branch, this, because x is just depending on the variable t alone. So this will be the normal dx, and then dt. Here, y is depending only on t. So we have dy dt. But here, this w depends both on x and also depends on y. So therefore, now the derivative is now the partial, not the normal ordinary derivative, but partial. So this branch will be partial w, partial x. This other one will be partial w, partial y. So that to get the w, the t, actually we take this branch, multiply by this. It's like we're taking this and this one, multiply together, and take this one and this one multiplies together. So we'll have partial w, partial x, this one, the change is dx, dt, plus this other one, partial w, partial y, and then the change here is dy dt. Or you can put it in terms of f, because w is a function, so we can say, or that rule can just be stated as df dt equals to partial f partial x dx dt plus partial f partial y, and then dy dt. So this is how we set that rule number one for chain rule. So example, find the derivative. So example one, find the derivative of w equals to x, y with respect to t along the path x equals to cosine of t and y equals to sine of t. Then find the w dt at the point where t equals to pi over 2. So this is a nice problem. So you see w is depending on x and y, and x and y are depending on t. So solution for this, solution. The derivative of w dt. So from 1, we have dw dt equals to partial w partial x times dx dt plus partial w partial y dy dt. This is just by definition. And this is a wxy. So clearly, partial w partial x will give us y. Partial w partial y will give us x. Dx dt will give us, when you differentiate a cosine function, you get a negative sine function. And dy dt, differentiate a sine function, you get a cos function. So then we just replace these values in the function. Dw dt will be partial w partial x is y. Dx dt is minus sine t plus partial w partial y is x. Dy dt is cosine of t. But where there's y, you put sine t. Where there's x, you put cos t from the equation. So cos x is cos x, y is sine x. So this is the same as sine t, not cos x. So minus sine t, x is cos t, and then this is cosine of t still. So this is dw dt. When you open this one, we have dw dt. Sine times sine is negative sine squared because of this negative sign. And then this is cos squared t, which can be written as cos squared t minus sine squared t. But you can simplify this one from double angle formula, knowing that sine cosine of 2a, since cos of a plus b is given by cos a cos b minus sine a sine b, then when you say cosine of a plus a, the same as cosine of a minus sine of a sine of a, which is the same as cosine of 2a is the same as cosine squared a minus sine squared a. So when you replace a for t, so cosine or cosine squared t minus sine squared t will give us cos of 2t. So therefore, dw dt is nothing but cos of 2t, the simplification of this expression. So when we say to find dw dt at the point where t equals to pi over 2, the same thing as saying cosine of 2 times pi over 2, so which is the same as cosine of pi, and cosine of pi is given by -1. So the answer to that problem becomes -1. Last example 2. If z equals to xy and x equals to sine t, y equals to cos t, then find dz dt. So solution for this solution, we say from 1, we have dz dt. So the role of w in 1 is z, partial z, partial x, this by definition on how to define dz dt by chain rule. So partial z, partial t, when you differentiate this function with respect to partial z, partial x, this will give us y. Partial dx dt, when you differentiate this one with respect to time, you get cosine of t. Partial z, partial y will give us x. Dy dt is minus sine t. And what you normally do, you replace y by its function, x by its function. So where this y, you put sine t, and then cos t, plus x, you put sine t. Actually, so where this y, you put cosine sine t from the equation. From the equation, x is y is cos t. So cos t, and then where this x, you put sine t, and then minus sine t. So that would give us cos times cos is cos squared minus sine squared t. And from what we have also seen previously, this is the same as simply cosine of 2t. So that's what we have. So in the next session, we'll give the second tool for chain rule. So thank you.